All right, let's talk data. It's literally everywhere. But have you ever stopped to wonder what prevents all that information from turning into a complete and total digital junkyard? Well, today, we're pulling back the curtain on the hidden architects of data integrity, SQL constraints and keys. Let's dive in. I mean, seriously, think about it for a second. Without any rules, you'd have total chaos. You'd get orders in your system with no customer attached. You'd have multiple users signing up with the exact same email address. Maybe even products with a negative price. The data would be messy, unreliable, and pretty much useless. So, what's the fix? Well, you meet these guys, the guardians of our data. Constraints and keys. Now, don't think of them as limitations. Oh no. They are incredibly powerful tools that make sure your data stays accurate, consistent, and totally trustworthy. They're the secret sauce to any well-built database. To really get their power, we need to shift our thinking. These aren't just restrictions. They're the architectural blueprint for your data fortress. They're what make your information strong, reliable, and secure from the inside out. So, what is a constraint, really? At its heart, it's just a rule. It's a rule you get to define on a database table to control what kind of data is even allowed to get in. It's kind of like setting the laws of physics for your own little data universe, making sure everything behaves just the way you expect it to. So let's crack open that rulebook and take a look at 4 of the most fundamental constraints. You can think of these as the essential building codes for any database worth its salt.
First on the list is not null. Sounds simple, but trust me, it's absolutely vital. This rule just guarantees that a column can never, ever be left empty. For stuff you absolutely have to have, like an employee's ID number or a customer's email, this is non-negotiable. You just have to have that data, period.
And check out how simple it is to put this rule in place. We're just using the alter table command on our employees table. This one line says that the employee ID column cannot be null. That means every single employee record has to have an ID. No ifs, ands, or buts. Okay, next up is the unique constraint. And yeah, this one does exactly what it sounds like. It makes sure every single value in a column is one of a kind. Just imagine a products table. You would never want 2 different products to have the same product code, right? That would be a complete nightmare. This is the constraint that stops that from ever happening. So how do we do it? Here's the code. Again, we use alter table, but this time we're adding a new constraint, which we're giving a name, UQ product code. Then we just say the unique rule applies to that product code column. And boom, no more duplicate product codes allowed. Now this next one is really cool. The check constraint is where you get to enforce your own custom business logic. Let's say you have a discount percentage. It can't be a negative number, right? And it probably shouldn't be over 100%. The check constraint lets you build that logic right into the database itself. And with a simple statement like this, you've basically built a security guard for your data. Now, if someone tries to enter a discount of, say, 110%, the database itself will throw up a red flag and reject it. It protects your data's integrity before a mistake can even be made. And finally, for our 4 fundamentals, we have the default constraint. And let me tell you, this one is a fantastic time saver. It automatically assigns a value to a column if you don't provide one yourself. So you could set every new user's status to regular by default, and then you only have to bother changing it when you're adding an admin. And the code is super straightforward. We just alter the user type column in our users table and tell it to use regular as the default. It's clean, it's efficient, and it keeps your data nice and consistent. So we've covered the rules that apply to individual columns. But now let's talk about the big guns, the structural beams of our database, keys. Keys are a special type of constraint that are all about identifying records and, most importantly, connecting our tables to one another. And the most important key of all is the primary key. This is the king. It's the ultimate unique identifier for every single row in a table. It has to be unique, and it can never, ever be empty. Think of it like a social security number for a person or the VIN on a car. It's the one thing that says, this is that specific record and no other. Now, this is a point that sometimes trips people up, so let's be super clear. Both primary and unique keys make sure values aren't duplicated. But here's the key difference. A primary key, like an employee ID, cannot be empty. Every single employee must have one. A unique key, though, can be empty just once. Think of a column for a spouse's ID. You might not be married, so that could be null. But if you are married, that ID has to be unique. See the difference? And now for the part where the real magic happens, the foreign key. This is the bridge that connects all your data together. It's a column in one table that points directly to the primary key in a different table. This is how you link a customer to all their orders. It's how you connect a blog post to all of its comments. It's what turns separate lists of data into a real relational database. Let's make this crystal clear with an example. So here we've got our customers table. Pretty simple. And you can see that customer ID is our primary key. It's the unique identifier for every customer we have. Okay, now here's our orders table. Notice it also has a customer ID column. Right now, it's just a column with numbers in it. But we're about to give it a superpower by making it a foreign key. And there's the link. By creating a foreign key, we're basically drawing a line from the customer ID in the orders table straight back to the customer ID in the customers table. This creates what's called referential integrity. It makes it physically impossible for your database to have an order placed by a customer who doesn't exist. This connection makes your data relationships rock solid. Okay, I know that was a lot of technical stuff. So let's bring it all back down to earth and make it really tangible. We can actually tie all these ideas together with a simple model we all know, a library. So just imagine this. The whole library, that's your database. Every single book on every shelf is a record in a table. The book's unique ID number, that little barcode they scan, that's its primary key. Now, your library card number, which also has to be unique to you, that's a perfect example of a unique key. And that basic rule that a book has to actually exist before you can check it out, well, that's a not null constraint right there in the real world. See? It all just clicks. So, at the end of the day, why does any of this really matter? It matters because without these rules, without this structure, data is just a bunch of noise. Constraints and keys are the guardians that step in and turn that noise into reliable, meaningful information. The kind of information you can actually use to make decisions. And this really says it all perfectly. They aren't just gatekeepers trying to stop you from doing things. They are the architects. They give you the power to build robust, efficient, and trustworthy systems for your information. They don't restrict you, they empower you. When you master these concepts, you're not just someone who uses data anymore. You become a designer of data systems. You have the blueprint to create databases that aren't just functional, but are truly elegant and reliable. So I guess the only question left to ask is, now that you know the rules, what are you going to build?